Can everyone hear me?
Yes.
Okay. Hi, this is Diu Ting. Good afternoon, everyone. And today we have some section to go through the fundamental of ODU. And first is ODU overview. And in this section, I'm going to introduce the overall architecture of ODU. First, I think we need to figure out where is ODU, and as we can see, ODU is in the middle part. And for upper level architecture, ODU connect to near real-time rig with E2 interface and connect to OCU with F1 interface. For lower level architecture, ODU connect to ORU with front hole interface. That is FHI. For this part, I think you can just remember the abbreviation. I think it's more easier to memorize. This is overall architecture of ODU High, and as first, I will introduce DU app module. And DU app is to configure and manage all the operations of ODU, and there are several sub modules in it. And first one is O1 module, and it used to receive configuration from high level architecture, and it can be also used to report the performance metrics or statistic and to higher level networking management. And the second one is EGTP manager, and it used to handle EGTP connection on F1 interface in terms of user plan. And the third one is SCTP manager, and it is responsible for establishing SCTP connections with OCU rig on the F1 AP and E2 AP interface respectively. And then UE manager, and UE manager handles UE context information as the DU app, because if users want to establish the connection to internet, it is necessary to get some information of context to let the network recognize this UE. So it also it still need a manager to handle the UE context in DU module. And the last one is cell manager, and it can also call us DU manager, and it used to handle all cell cooperation as the DU app. Okay, next is RLC module. And RLC module, it provides service for transferring the control and data message between MAC layer and OCU. And the last one is MAC module, and its stack scheduler is internal scheduler. Okay. And MAC module is to interpret the large channels, and it does the scheduling with its internal scheduler. So let's move on to interface part. And for lower part, we can see MAC connect to FAPI TM. The whole name is translator module. Okay, so it connect to FAPI TM by FAPI interface, and FAPI TM is like its name, and it used to do translating work, and because ODU High is developed by Redis, and ODU Low, like we can see L1 app, is developed by Intel. and their data formats are not consistent, so it still needs some translation to let them communicate with each other. And after the translation, L1 app will handle some work like modulation and transmit the data to RU through the front-hole interface. And of course, if this direction we explain is from upper part to lower part, but if the direction invert, the concept is still the same. And in the upper part, for connections with ODU, there are two types of connection. This one, okay, and the left one is for user plane, and that is F1U. And user plane is used to transmit user data, like we visiting website or uploading image, watching video, something like that. And another side is for control plane, and that is F1C. It used to transmit control signal. For example, maybe sometimes the higher component or architecture want to do mobility management, connection management, or get some parameter to monitor the user. And the most right side is E2 interface, and E2 interface is for near real-time rig, and the concept is the same, but it only has control plane. So this interface can monitor the performance metrics, and near real-time rig can also send the control signal back to SCTP manager. So now I will introduce some our implementation option to let everyone know what we are working on. I think as first I need to briefly introduce the WLS library, because the interface I'm going to mention later is based on this technology. And WLS library, the whole name is Wireless Service Library, and it mainly supports shared memory and buffer management. And it is based on TBDK library. And what is TBDK? And this library is used to handle communicate of different process, and it can make communicate be more efficient. Okay, so FAPI interface and Intel API. These two interface we will mention later, and these two interface are based on WLS library. And I think we need to notice that is front-hole interface is purely use DPDK library. It will not use WLS library. It's quite different. Okay, so the first option is the testing of ODU law and the TestMac developed by Intel. And I think the main purpose is to test the FAPI translator module. As I just mentioned, ODU High is developed by Redis, and ODU Low is developed by Intel. So their data pipes are not consistent. So it need to pass by some translation. So I think for this part, I think it should be noticed is that TestMac module is developed by Intel. So it's not real ODU high. For this part, it's just for testing the connection. Okay. So let's move on option 2, and this part is to test the front hole interface. We can see here, and it's the same as option 1. It's just for testing, and IU sample app and audio law are for testing the connection, and it's not a practical component. And the option 3 is integration of audio law, audio height, and the ORU. I think we can say that is our final goal, and it can divide it into 2 modes. First one is timer mode. As we can see, this combination will not include a resource unit, and the second one is radio mode, and it will fully integrate the these 3 components. And that means we integrate the whole LoRa module successfully. So it is our real goal. I think that is all my part. Anyone have question?
Yes, hello. I have a question.
Oh, okay.
So, please go back to the ODU architecture.
ODU architecture. Oh, okay.
Oh, yes, this one.
Oh, this one.
Yes, this one.
Okay.
My question is, why does Mac why doesn't Mac split into uplink and downlink? Because radio link control is split into uplink and downlink. Is there any reason?
I think sometimes if I think you need to see the figure about the protocol stack, and if we want to communicate with OCU, maybe we need to pass by the RLC downlink or uplink. But if we just want to report the E2 interface, we will communicate with maybe you or DU app. We will communicate with DU app directly. We will not pass by IRC. And for downlink part, maybe sometimes into interface will control the scheduling, so it will send a control signal down to the DU app, and DU app will forward the signal to Mac directly. Did I answer your question?
Maybe yes.
Okay.
Okay, thank you.
So does any other person have question? Or okay.
Let me have a quick comment to Yuehuan's question. The Mac will be tightly they don't split into downlink and uplink because according to different frame format configuration, we may allocate different slot for uplink, different slot for downlink. So according to the operation, it take put everything together, so they don't split into downlink and uplink. They handle it all together. Thank you.
Okay, thank you.
So now I will start my sharing, and I will forward the permission to Jackie.